polymerization reaction. So now we are going to start off with the condensation. Condensation, polymerization reaction. Can any say what do you mean by condensation polymerization reaction? In addition, what we are repeatedly added the monomer units to make an polymer. Okay, a molecule, that's a big molecule. Okay, we are constantly adding the monomer. Here in condensation reaction, so we need to remove some material or something to make the polymerization formation. So the definition for this is repetitively, we can use that also, repetitively condensation of bifunctional monomers occur usually with the loss of simple molecules such as water, HCl, methanol, etc. Yes, Gokul, you are right. Exactly, Meghana. Law of water. So, by what we read, we'll just compare the addition with your condensation polymerization. So, for addition reaction, what did we are continuously adding monomeric units without any changes and all, or without any removal, we are just continuously adding by transferring or maybe an radical or transferring of an cation or transferring of an anion, continuously add. But in condensation reaction, if we need to add something, we need to lose something. So that is called condensation reaction. So we are not gathering a bulk. Instead of that, we are making one molecule, removing some component, or it may be water, or it may be an HCl, or it may be methanol. Removing a small molecule and by addition of your monomer units, that is either it be an bifunctional or trifunctional. Can I say what do you mean by bifunctional or trifunctional monomer? So bifunctional monomer means if monomer having two functional group. Okay, will you get it? So it to say it is a monomer. So that one monomer having and two functional group. It means to say, give an example, right? Suppose CH2 bond CHBr. Just this example. Here this double bond will also act on one functional group, and this Br is also acting as functional group. So this is one unit, and this one monomeric unit will contain two functional groups. This is called binary. Bifunctional monomer. Okay, like that. Can you give another example for trifunctional? Can you say by trifunctional? Can you give me the example of that? Nikhil, class ಅಲ್ಲಿ Nikhil. Okay. Monomeric units have three functional groups. Yes, exactly. Rana, you're right. Sakshita. So it is to say this one monomer will contain three functional groups. I can write like this also. 1, 2, 3. So this is a monomer and which contains three of its functional group. That is called a trifunctional monomer. Okay, able to understand? Google, I told you recent the people got you for 8 group elements. You didn't anything. Okay, next. That is called condensation polymer. So know that what is by condensation polymer, and we are going to see what do you mean by functional and now let us see the type of it and how we can. So one thing we don't have that much of a mechanism like what we studied for additional polymerization. We have simple thing. I'll give one example. So see now from now I'll write one example. You should write one more example. Okay, so that it could have been easy to understand. Okay, so now we are combining terephthalic acid with your ethylene glycol. Okay. So now we are combining this component and this structure. So represent n number we are going to. Okay, this is your terephthalic acid and this is ethylene glycol. So what happened? See this here how we are. So this you can read like this. Or is it right? COA group you can write this. So I'm writing it out. And what is my resonance? So here also I do the same thing. Finding this group. Already 3 minutes done. Huh? We are taking this n number, that's why we're taking n number. Can anyone notify? Can anyone notify what? How many groups or what are the atoms removed from this two? I'll just make a note on it. See, we are just writing C double bond, so OH is remaining from here, and we have benzene ring, and here COH is moved. Okay, so here now we remove again H group OH, and here we remove. Is it fine? Is fine. So what did from the carboxylic group from COOH we removed OH. We removed OH group, and I wrote here. So what are the things we are not included for the structure? I'm right here. This called terrin cron. Okay. So OH is removed. I wrote here, and from this carboxylic group, we H, and here OH and end H. So totally we got H2O. Right? See, molecule of water, another molecule. So what we are getting from the each molecule of the terephthalic acid and ethylene glycol, we are getting 2 molecules of water. Is it right? Right. From the each molecule of terephthalic acid and ethylene glycol, we got 2 molecules of water for the production of terylene. For the production of terylene. Now also you are not listening my voice properly. Now also it's I'll repeat. Voice yeah. Okay. Tetralic acid structure, carboxylic group, benzene ring, again carboxylic group. This. Okay. Can I log and log in? This is fine. I will do that. Okay. Am I audible now? Okay, fine. So now, terephthalic acid means carboxylic group, benzene ring, carboxylic group. Ethyl glycerol means OH, CH2, CH2OH. Simple structure. So what we did, we removed OH here and H here. Same, OH here, H here. So we joined everything. So this is called trilene or dectron or dectron. Okay. So from the each molecule of terephthalic acid and ethylenic glycol, we are getting 2 molecule of water. Okay. 2 molecule of water. Copy down fast. Done. Okay. Next. So this is the same thing. We are removing the water. So this is the thing you need to know. So now let us see some important additional polymers. Okay. So first one, polythene. Okay, polythene. Polythene means you know that, right? We are using the plastics that is called polythenes. So polythenes or the additional polymerization from your ethene. So you should know this thing. You can make chart out of it. So one side polymerize names, and here what are the monomeric units and what is the structure of it. So if you made that chart, it could have been easy for you because this is going to ask you for 2 mark structure. Okay, next. So I'll write the structure now. N-ethene. Ethene means CH2 double bond. CH2 will gives you a number we are using, and we are getting like this only. Double bond CH2. So this is called ethene, and this is polyethene. Okay. So we have 2 types of ethene, that is lower density polyethene and high density polyethene. Okay, low density polyethene and high density polyethene. So what is a much more differences? This is low density polyethene is having the pressure of 1000 to 2000 atmosphere. ATM means atmosphere. And which having 350 to 570 Kelvin temperature resistivity. Okay, temperature resistivity. And this is more flexible. Okay, this is more flexible. What is this? Low density polythene. In high density polythene, having 333 Kelvin to 343 Kelvin pressure resistivity and 6 to 7 atmospheric pressure, and it is less flexibility. So we are using this for like what is a lower density polythenes for pipes and toys, okay, and bottles. We are using it up. And high density polythene, we are using it for dustbins, okay, buckets, and bottles, okay, we are using it up. So these are the two types of polythene we have: low density polythene and high density polythene. Low density polythene means it's having 1000 to 2000 atmospheric resistivity with 350 to 570 Kelvin temperature resistivity, and it is more flexible and easy to bend and made a shapes. And we are using it in pipes formation and toys making and bottle manufacturing. Again in high density polythene, so it having a temperature of 6 to 7 atmosphere, so 333 to 343 Kelvin, and which is less flexible, and we are using it for dustbins, buckets, and bottle manufacturers. Okay, fine. So this is the first of your polythene. Second, you have polythene, then PVC, PTEE, then PAM, everything. So we'll continue it in tomorrow's class. Okay. Only start doing one thing, start making a chart. Okay. Monomeric unit, polymer, and structure. So that chart will help you out. Any doubt? Okay, then.